Greetings one and all, and today we are going to discuss about acylglycerol. Acylglycerol is basically uh, we can chemically define them that these are the condensation products. These are the condensation products of fatty acids and glycerol. Or we can also call that these are the these are the esters of fatty acids and glycerol, which means one glycerol combines with three fatty acids to form acylglycerol. Now, what is it? What is this structure combined of? So basically, esters of fatty acid and glycerol is formed by the ester bond. What is an ester bond? Ester bond is a bond which is formed by the linkage of alcohol, linkage of plus alcohol plus fatty acids. It can include any type of organic acid, so we are writing here or fatty acids. Now the bond which is formed between alcohol and fatty acids by removal of water molecule or by condensation process is known as ester linkage. And that ester bond, this is not ester linkage, it is ester bond, which means bond between alcohol and fatty acid by removal of water or by condensation process, that is known as ester bond. And that process by which it is formed is known as esterification. Apart from which, when we are going to remove three water molecules, this is removed in such a manner that first let us discuss the structure of glycerol. What is glycerol? Actually, glycerol is basically trihydroxy alcohol, which means it is having three alcohol which are connected together with three carbon atoms as well as three hydroxyl groups. And here trihydroxy alcohol is also shown in the diagram here as well. That here there is one alcohol, there is one alcohol, there is another one, there is another one. So there are three alcohol which are combined together uh, and bonded together, which form the structure of glycerol. Now, how is the bond actually formed? So inside this, if there is one glycerol, let me just raise it up. Hello. So here, in glycerol, basically how the bond is formed is in such a manner that in condensation, hydrogen atom from the hydroxyl group of glycerol is taken and hydroxyl group of the fatty acid is taken, due to which both of these are liberated out and they form a water molecule, and that water molecule causes to form a bond between them, which is known as the ester bond, and this process is known as esterification. Same goes with the other alcohol. Here that alcohol molecule is then having its hydrogen atom liberated and carboxylic acid, and there we have hydroxyl group liberated from the fatty acid. Accordingly, both of these are liberated and that forms this structure which is known as triglyceride. Basically, we are going to define what is a glyceride. So here we have glycerol, and again there will be same process will occur. Hydrogen from glycerol and hydroxyl from fatty acid will be taken, and then it will form a water molecule, due to which it will form this structure. Now, basically, this is the structure, but one thing which we need to here discuss is that we need to discuss the structure of fatty acids. What is fatty acid? Fatty acid is basically an it is basically an acid. It is basically a carboxylic group, a carboxylic acid group, carboxylic acid group, which is attached with a long chain of carboxylic acid group, which is attached with long chain of carbon hydrocarbons. Carboxylic acid group, which is attached with long chain of hydrocarbon, which is considered as hydrocarbon tail as well, because in the structure of phospholipid we are going to further discuss how it forms a hydrophobic tail. So it is a carboxyl group attached with a hydrocarbon tail, which collectively forms this structure. Basically, it's hydrocarbon chain, and this complete structure of fatty acid is also considered to be uh, hydrophobic. Of course, these are hydrophobic because these are lipids, and that is hydrophobic chain, or we can also write it as hydrophobic tail. So, yeah, that's all. I mean about fatty acids. And now, if for suppose there are three fatty acids with one glycerol molecule, But for suppose if we are having only one fatty acid, if there's only one fatty acid which is attaching with one glycerol, then that structure will be considered as a monoglyceride, and the structure final product will be a glyceride. What kind of glyceride? Monoglyceride, because there's one fatty acid. If there are two fatty acids, then that would be a diglyceride. Similarly, if there are three fatty acids, that is triglyceride. And triglyceride structure is also known as triglyceride or triacylglycerol, which means that it is the structure which we can ultimately call as acylglycerol or triacylglycerol or triglyceride. Apart from which, that is a neutral lipid, that is a neutral lipid. And as it is a neutral lipid, what kind of why is it a neutral lipid? Because as you can see the diagram, that here this charge bearing hydroxyl group of fatty acid is removed. Charge bearing hydroxyl group of fatty acid is removed. It is liberated completely from in the form of water molecule. Same goes with this, same goes with this. But here this hydrogen atom, on the other hand side, this hydroxyl group of glycerol is having its hydrogen atom captured, liberated in the form of water molecule, while the fatty acids uh, also create a bond with the hydroxyl group. What I want to say here is that hydroxyl group, which is charge bearing, is liberated out, but that solves the first condition for fatty acids. Secondly, glycerol is basically uh, having hydroxyl group as well, and that hydroxyl group is then occupied by fatty acids. That fatty acids form a bond with the hydroxyl group by liberating a hydrogen atom. That is why it causes to form a stable structure, due to which there is no charged group or charged atom which in the structure of glycerol and fatty acid collectively forming the triglyceride. So here in this complete structure there is no charged group hydroxyl is removed, and here hydroxyl group is being forming a bond with the fatty acids, due to which it collectively form triglyceride, which is a collective structure which is neutral lipid. And apart from this, we are also having some other points, that inside the human body, average human body, inside average size of human body, there are 16 kilogram of fat. There's 16 kilogram of fat, out of which this 16 kilogram of fat contains 144 into 10 s power 3 kilocalorie energy. All right. And apart from this, there is difference between saturated fatty acids and unsaturated fatty acids. So we are going to discuss here what kind of structure it is. So here basically there are two types of acylglycerols which are dependent on the structure of fatty acids. So two types of acylglycerols are there: saturated acylglycerols and unsaturated acylglycerols, which are dependent on structure of saturated fatty acids and unsaturated fatty acids. So saturated acylglycerols are having a single bond. These are having a single bond. They are having a single bond between carbon to carbon, while saturated fatty acids are having single bond, and unsaturated are having double or triple bond, double or triple bond between carbon to carbon atoms. And there are some characteristics of them as well. These are found in animals in the form of fat. As these are fats, these are solid. As these are solid, these are having high melting point. On the other side, these are found in plants. These are in oil form, which means these are in liquid form, which means these are having low melting point. Low melting point. Apart from which, we are having other structures, uh, other characteristics of them as well. That inside the structure of inside the structure of of a single bond of saturated fatty acids. Inside the saturated fatty acids, there are more number of hydrogen, less number of carbon. Inversely, in unsaturated fatty acids, there are more number of carbon, less number of hydrogen. That is why they produce a blue flame, and that is why they produce an orange flame. Apart from which, they also produce, these are stable. I mean, These are more stable and less reactive. These are less stable and more reactive. Apart from which, um, yeah. So here these are more stable. These are less stable. These are more reactive. These are less reactive, and accordingly, they are also having other characteristics. Let us discuss the example as well here. So here these are stearic. Example is stearic acid. Stearic acid is saturated and that is consisting of 16 carbons. If I am not wrong, it's consisting of 18 carbons. So it consists of 18 carbons and its formula is C57H110O6. And that is basically found in beef and mutton. Beef and mutton. After which, when it comes to example of unsaturated one, unsaturated is having its example as um, linoleic acid, lino, linic, linoleic acid. I'm not sure about the spell, but that is linoleic acid. And apart from this, uh, that is basically consistent of 18 carbons as well, and that is found in cotton seed. That is found in cotton seed. It's having its formula C57H104O6. And apart from this, let us discuss some other points as well. That here, uh, hydrocarbon chain is in unsaturated and saturated fatty acids. The hydrocarbon chain is straight, whereas in the unsaturated fatty acids, the hydrocarbon chain is bent. Apart from which, we are also having examples such as stearic, palmitic acid, myristic acid are all included in the examples of saturated fatty acids. And when it comes to other points, other examples, it is having higher, it's having higher solubility. If I'm not wrong, it's having higher solubility, and it is having lower solubility. Accordingly, if it is having higher solubility in what, it is having higher solubility in organic solvents, and lower solubility in organic solvents, and that is, as it is having higher solubility in organic solvent, it is having hydrophobic condition. It is hydrophobic, and this one is this both are hydrophobic, but this is more hydrophobic. This is less hydrophobic. Mhm. And which one is more beneficial? Uh, which one is more beneficial to us? Which is more beneficial? The more beneficial one is the oils, because oils are the one which are more beneficial to the human body, because they decrease the LDL, low density lipoprotein, and they increase the LDL. They increase LDL. They decrease LDL. So these are a few points that I wanted to discuss today, and apart from this, uh, um, these are the basic differences between them. And apart from this, apart from this, we are also having some other MCQs point regarding glycerols and fatty acids. That here, uh, glycerols, how many types of fatty acids are there? So fatty acids, there are almost uh, 30 different types of fatty acids. 30 different types of fatty acids, out of which some of these are discussed downside in the saturated and unsaturated fatty acids. And what are the number of carbon atoms in fatty acids? So fatty acids is having these carbon atoms in even number from 2 to 30. These are some points which I wanted to discuss. And another point, that lipid which is the most abundant lipid here. So acylglycerol is the most abundant lipid. I guess that's all, and we'll meet again in